Hello and welcome to this tutorial on configuring Singularity OSPF version 2. For this lesson, I have prepared a sample file beforehand to which you can download via the Moodle course page or the link given in this video description down below. In this lesson, we cover several objectives on configuring OSPF version 2 for Singularity. We'll look at configuring the OSPF version 2 router ID, configuring Singularity OSPF version 2, adding networks, configuring the OSPF interface priority, basically to influence the DR and the BDR election in multi-access networks. And then we look at implementing modifications to change the operation of Singularity OSPF. And towards the end of the lesson, we look at configuring OSPF to propagate a default route, as well as verifying. Okay, verifying is something we will do as we go through each of these key objectives. Now you will notice that in the sample file that is given, you have a topology where you have three routers, R1, R2, and R3. You can see that the routers in the topology have a startup configuration. However, they haven't been configured with interface addresses, only for router 2. Router 1 and router 3 I've only configured, I haven't configured any basic configurations on those two routers except for router 2. Okay, so what I'd like you to do is, even before you begin on this video, if you could just pause the video, go straight into R1 and R3, configure the host names according to the topology given, configure the basic, do the basic configurations like no IP domain lookup, line console passwords. Those are very important things you need to configure. They are not the key objectives of this video. However, I would like you to do that before you move into the actual meat of this tutorial. Now, so the routers in the topology do not have, especially for R1 and R3, do not have interface addresses configured. There is currently no static or routing or dynamic routing configured on any of these routers. All interfaces on R1, R2, and R3 except the loopback one on R2. That's this one here, connecting to the internet cloud. Okay, that's just line drawn across just to simulate that. In fact, it's just a loopback. Okay, so all of these interfaces are all inside area 0 except for loopback 1 connecting to the internet cloud. Okay, so the ISP router is going to be used as the gateway to the internet of the routing domain. So right at the end of the lesson, we will configure that interface as a default gateway, and then we'll ask OSPF to propagate the default route information through OSPF across to the other three routers. So the first thing I would like us to look at is just to check R2. We open R2, and when we go to the command line interface, you will notice that I've already assigned done basic config. I've used Cisco and class, so just use Cisco and class for to log into the router. And you might want to do the same to R1 and R3. Okay, so you will notice that if I do a show IP int brief, I've already configured interfaces on R2. Okay, so R2 has a gigabit 00 interface configured with an IP address, gigabit 01 interface configured with an IP address, including two loopback interfaces, loopback 0 and loopback 1 with IP addresses. So R1 is configured with all the required configurations to set up basic configs, including interface. And what I'd like you to do now is go ahead to R1 and R3, configure probably the host name, basic configs, and then move into configuring interfaces, G00 with the given IP address there. You'll see that this is supposed to be the 10.1.1.4/30 network. This end will be .5. This will be 10.1.1.12/30. This end will be .14. Okay, so you configure the appropriate IP addresses, turn the interface on, configure the loopback addresses also. And do the same with R1 and R3. Okay, so pause the video, do that quickly, and then we go straight into configuring OSPF on all, enabling OSPF on all 3 routers. Okay, so we start off by looking at R1. Okay, so R1, I'll go into R1. I won't go into all the details of configuring basic settings. I only configure the host name. I'll just go to int G00 and interface gigabit Ethernet 00. Supposed to have, I just add a description. This is linked to R1. Okay, oops, description linked to R2. Okay, IP address, and that's supposed to be 10.1.1.5, 255.255.252. Okay, no shut. That should turn the interface on. Okay, I exit out of that interface config mode and type int 01. Okay, IP, before IP address, I'll just add a description. This is linked to R3. And then IP add 10.1.1.14, 255.255.252. Okay, remember that's /30. And then do a no shut. Okay, exit. Int LO0, loopback interface 0. And we'll give this a host address, IP add 10.1.1.1, 255.255.255.0. Okay, and it says overlap, so I think I made a mistake here. This is supposed to be 10.10.1, yes. So I'll repeat that and add that 10.1.1, correct? So all good. Okay, no need to type no shut because the loopback interface was already turned on. And that, do a WR to save the config, and I'll move across to R3. And then I'll just repeat the same thing with R3. I'll configure R3 with the IP address, int G01. I add a description first, link to R2, IP add 10.1.1. This should be 10, 255.255.255.252. Do a no shut. Okay, exit, go to int G00, description first. This is linked to R1. IP add will be 10.1.1. This is 13, 255.255.255.252. Do a no shut, and that's done. Save that. Okay, so once you've configured the IP addresses, I forgot something. Hold on. I'll just go back and configure int LO0 IP add. Okay, so interface loopback 0. You will notice this is referenced, this topology here is referenced, it's taken from the lecture note slide number 4. So I've used that image, I've built a packet tracer file, so you can just add a bit of information there. And this is supposed to be the 10.10.3.0/24 network. So that means this will be .1. Okay, this interface will be .1. So that's the loopback. Okay, so we'll just add that in there. IP add 10.10.3.1 255.255.0. Okay, done. Save that. Okay, so by now you should check and ensure that all interfaces have been configured. You could do a show IP int brief just to verify on router 1 and router 3. So we go into the first step, and that is to enable Singularity OSPF version 2 on router 2, and then we'll make our way down to router 1 and router 3. We'll configure, no need for us to configure the router ID at this stage. I would like to show you what happens if we don't configure the router ID. What addresses does the router use when we do not configure, when we do not explicitly configure an IP, a router ID. Okay, so we go straight to router 2, and this is what I'd like you to do. When you're in router 2, when you are setting up, when you're configuring, hold on, when you're configuring OSPF, okay, like every dynamic routing protocol, the configurations are very much the same. For instance, if you're configuring EIGRP, you would type router EIGRP process ID. If you're configuring OSPF, you'll also do the same. Router OSPF process ID. So the process ID is this configuration is done in global config mode, and the process ID value represents a number between 1 to 65,000. So let's just type that. Go router OSPF question mark. Can you see that the process ID ranges from 1 to 65,535? And this value is usually selected by the network administrator. So you decide what process ID you would like to give. The process ID value is also locally significant. And best practice is to apply the same process ID across all OSPF-enabled routers within the same routing domain. So here we're going to be using OSPF process ID of 10. Okay, so I type router OSPF 10, I hit enter, and notice as soon as I hit enter, it takes me into the config router config mode. Okay, so the next thing I would like to do is I'll just type in a question mark so you can see what set of parameters you could key in here. So we have area, autocost, default information, distance, and so on. The list goes down right down to the last one, router ID. So we will be using these commands throughout this module. The first one I'd like us to use is network. Okay, so we add in network, and if you look at R2 is connected to three different networks which we would like to be part of area 0. That's loopback 0, the 10.10.2.0/24 network, 10.1.1.4/30 network. That's this one, and then we have the 10.1.1.8/30 network. So these are three networks, 1, 2, 3. This LO1 is not part of area 0, so we're not going to include it in the network when we're defining the network. Okay, so we type network. First network will be 10.10.2.0. Now notice when it comes to the subnet mask, you will now enter OSPF wildcard bits in here. Okay, if you're going to be specifying the certain network here. So /24 will be 0.0.0.255, and we have to make it part of area 0. Okay, so that's first network. The second network, I'll just press the up arrow key to repeat that same line, and then next network will be 10.1.1.4, and it's /30, so the last one 255.252. You subtract that from 255, you will get 3. Okay, so that's going to be .3 area 0. Remember, you're just flipping. To get the wildcard mask, you're just flipping the subnet mask, flipping or subtracting everything from 255. Okay, so the next network is the one on this end. Okay. So 10.1.1.8, and okay, same wildcard mask, area 0, hit enter, and do a WR or copy run start to save that. So we'll leave R2, we'll go straight to R1, and we'll apply the same. Now with R1, notice R1 has to also be enabled with the OSPF ID. So router OSPF 10, process ID of 10, and we go network, 10.10.1.0 1 2 3 255. We're flipping that subnet mask. It's part of area 0. Repeat the same command, and I will put in 10.1.1.12, and this is going to be 3 area 0. I will add 10.1.1.4, flip that, and notice something's going to happen here when I enter 10.1.1.4. It will start establishing neighbor adjacencies as soon as you start configuring OSPF. Notice what happened here. OSPF5 adjacency form process 10 neighbor router 6400.0.1 on gigabit 00 went from loading to full. Okay, remember those 7 states? Okay. init, xstart, so on until it reaches full state. Okay, so convergence has been reached. Okay, so that's for router 1. I just need to make sure that this is saved. Okay, let's go to router 3, and we do the same in router 3. We go conf t router OSPF, hold on, router OSPF 10, network 10.1.1.8, 1 2 3, that's less 30, so again remember that area 0, this is part of area 0. I repeat the same command. This is going to be 12. Hold on, what's happening here? It's going to be 12. Okay. And I need to enter network 10.10.3.0 2 3 4 area 0. Okay, and that's done. Again, when you observe what's happening here, it's simply OSPF is now been enabled, and routers are starting to form adjacencies. They're starting to move from the different stages, beginning in state 1, all the way up to the final state, which is reaching convergence. Okay, so you see it goes from loading to full. Okay, so that happens as soon as you begin to configure OSPF and add the networks on each of these. Okay, so please do take note that this is oops, let me change that. Just change the field color here. This is not part of what's happening here. Loopback 1 on where the R2 is connected to the internet cloud, that's supposed to be in a different area. Okay? It's not part of area 0. This is area 0, sometimes known as the backbone. Okay? It's the area backbone area. Okay, so this is not part of this area here. All the other interfaces on R1, R3, and R2 are all part of area 0. Okay, so the next thing, we've just configured the Singularity OSPF on all, enabled OSPF on all routers. The next thing we need to do is verify. Okay, so if I go to router 2 and I type show IP OSPF, I just put question mark. Okay, so there's a couple of commands I could use here. I just put interface, hit enter, and you'll see several things. Okay, so you'll notice that R2, router 2 uses, okay, process ID of course is 10. We've defined that when we configured this. Router ID, interestingly, it uses 64.100.0.1. So I'll just note that here, and then we'll explain why it used the router ID. So this is R2. Okay, let's check. Hold on, let's go back there. Another thing you will notice here is, let's see. It says, okay, gigabit Ethernet 0 is up, network type is broadcast, state is designated router. Okay, state is designated router. Okay, so again, notice that this is a DR. R2 happens to be the DR. Okay, let's check router 3. When we type show IP OSPF, let's use interface. Okay, again, process ID same 10, router ID is 10.10. This uses the loopback address. Did you notice that? It used the loopback address. So that's router 3. And let's check what kind of a router, what role does this router play. Okay, so again, network type is broadcast. Remember, LAN, Ethernet networks, when you connecting routers in Ethernet networks, they're referred to as broadcast. Okay, broadcast. Point to point is a non-broadcast. Okay, so you do not really need this election to take place. But you can already see that R3 has now taken on the role of being the BDR, backup designated router. Okay, so I'll add that in BDR. Let's see what role router 1 is or plays. Okay, hold on, show IP OSPF interface. Okay, so router 1 uses router ID of 10.10.1.1. Again, you can see that it's the loopback it used. That's R1, and let's see what role this is. Okay, so you can see that gigabit Ethernet 01 is up, line protocol is up, internet address so and so, network type broadcast. One more thing, cost is 1. There's another thing you need to priority is also 1. Okay, it's the default. So this is the gigabit 01 that's pointing that way. State DR, loopback interface is treated as a stub host. Okay, that's pointing to the loopback. Okay, so it's pointing to the DR, and this is neither a DR nor a BDR, so it will be a DROTA. Okay, so designated router, backup designated router, R1 is neither a DR nor a BDR. Now, what's interesting about this? Why did the router decide to use router ID of the loopback 0, loopback 1 for R2, R3 it used the loopback 0, R1 it used loopback 0. Okay, so router ID has two important roles. The purpose of the router ID, remember it's a 32-bit value represented as an IPv4 address, and it uniquely identifies all OSPF enabled routers. So every OSPF packets, when they are exchanged between the routers, they include the router ID of the originating router. Now, every router requires a router ID in order for the router to participate in the OSPF domain. Two main reasons why a router ID is required. One, participating in the synchronization of the OSPF database. Number two, to participate in the election of the DR and the BDR. Okay, so the question really is, we did not assign any router IDs when we were configuring this. So how did it end up with these router IDs? Well, the thing you have to observe here is that router IDs can automatically be created by the router itself if you do not explicitly define one, and it will usually use loopback address or the interface address. It will use a loopback address if there's one configured. If not, it will use an active interface address if there's one configured. Now, what if there's an interface address, active interface address, and a loopback address configured on the router? It will go for the highest interface address or the loopback address. Okay, so let's look at R2 as an example. R2 picked up router ID of 64.100.0.1. Why did it not use loopback 0, 10.10.2.0? Well, because loopback 01 IP address is higher, 64.100.0.0. That's higher than all the other addresses. So you notice it happens that the higher router ID gets to be elected as the DR. Now, why is that? Remember, because the priority value PV is 1 by default, and it happens that all these three routers have the same priority value of 1. So there's a tie in the PV, or the priority value. So the next thing they're looking at now to determine who gets to be the designated router, who gets to be the BDR, is the router ID. Okay, so you can see that router 2 becomes the DR, next highest is 10.10.3.1, gets to be the BDR. And then you have router 1 with router ID of 10.10.1.1. Of course, you can change this. You can either change this by explicitly configuring router IDs on the three routers. Say, for example, you could go ahead and type, okay, why not we give router 1 1.1.1.1, and router 2 2.2.2.2, router 3 3.3.3.3. Okay, and obviously, if you stick with the same priority value, you will end up with router 3 being the DR, okay, and router 2 being the BDR, okay, because of the higher value in the router ID. Okay, so that's always the router ID order of precedence. The router ID is derived based on three criteria. It's explicitly configured using router ID, and which in this case we never did. So the router chose the highest IPv4 address of any of the configured loopback interfaces. If there are no loopback interfaces configured, the router chooses the highest active IPv4 address of any of its physical interfaces. Okay, so I hope that makes sense. You do take note of that on how this router ID was all configured. Okay, so we've configured the OSPF, we didn't configure router ID. We'll change that later on. We've configured Singularity OSPF version 2. We haven't touched the OSPF priority value also to influence the DR and the BDR election. The first thing you need to observe here is, of course, how the router ID was configured or was determined, and why the router ID is important in this case. Okay, so the next thing we will now look at is modifying the router ID, or explicitly configuring the router ID. So we will go ahead to router 2, and we'll go conf router OSPF, same process ID 10, and I'll type router ID. You see, it's going to ask me now. So I'll add 2.2.2.2, hit enter. And notice it tells me to reload or use clear IP OSPF process command for this to take effect. So I'll do a clear IP. It's just basically going to force a re-election. Okay, clear IP OSPF process. Okay, clear IP OSPF process. Done, exit. Set all processes, yes. Okay, so it's resetting everything on router 2. We'll go back to, by the way, as soon as we just change that to 2.2.2.2, let's see what happened here. Let's go back and check. Let's do a show IP OSPF int and see. Okay, so notice the process ID is the same, router ID is now changed to 2.2.2.2. Okay, priority value is still 1, priority of 1, network type is still the same, broadcast is still a broadcast network, but you can see that it's no longer a DR. Okay, it's no longer a DR. A re-election has been forced. Let's check, just by looking at this, we can tell that router 3 should be the DR now. Okay, so I'll just repeat the same thing here. Show IP OSPF interface, And sure enough, router 1 is now the DR. Okay, oh, hold on, let's see. 10.10.1, 10.10.1.14. No, it will be this one. Okay, so if we check that, show IP OSPF process interface, yes, it should be router 1, okay, as the DR, simply because this loopback is 10.1.1.14, okay, 10.1.1.14. So you can see that this one is also 10.10.1.5. Okay, so this uses you can see here gigabit 01 line is up, router ID 10.10.1.1, state is DR, and priority is 1. Okay, priority value is 1. Okay, so let's go ahead and change the others also. We'll change router 3 to 3.3.3.3. We'll change router 1, router ID to 1.1.1.1. And then we'll just keep the same priority value as it is. Okay. So conti router OSPF10 router ID. This is 1.1.1.1 and clear IP OSPF process. Yes. KWR. Let's do the same to router 3. OSPF10 3.3.3.3 and here IP OSPF process. Yes. Okay, so we've changed the router ID on all three routers. So I've just given the simple 1.1.1 and 2 and 2, 3.3.3.3. So this will now make router 3. Let's check router 3. Let's do a show IP OSPF neighbor. Okay, so you can see neighbor. So router 3 is looking at router 1 with a full state. Its relationship is BDR. It's looking at router 2 full state BDR. Okay, let's check show IP OSPF int. Okay, so notice it's the DR now. Okay, router 3 is the DR and router 2 gets to be the BDR. Okay. Again, because of the value in the router ID. The higher the router ID, it gets to determine who gets to be the BDR, DR, and the BDR. The next thing I would like us to do is modify the priority value. Okay, so we've explicitly configured the router ID. We cleared the IP OSPF process to allow the election, to force the election to take place again. Now we're looking at trying to modify the priority value so that we can see how this is going to influence the DR and the BDR election, okay, just by changing the priority value. Okay, so that's the next thing we need to look at. But before we do that, I want you to observe the adjacencies. Okay? If you look at, for example, you go to R2 and you type, when we say observe the adjacencies, you should be thinking about neighbor. Okay, so you have this relationship state full DR or full BDR. When you go back to the nodes, the full DR, the router is fully adjacent with the indicated DR neighbor. And these two neighbors can exchange hello packets, updates, queries, replies, and even acknowledgements. Okay, full DR. Full DER, full BDR, the router is fully adjacent with the indicated BDR neighbor, and the two neighbors can exchange hello packets, updates, queries, replies, and acknowledgements. Where you see a full and DROTA, full or DROTA, you will notice that the router itself is a DR or a BDR router that is fully adjacent with a non-DR or a BDR. Okay, so remember, a DROTA is a non-DR or BDR. And these two neighbors can exchange hello packets, updates, queries, replies, and so on. If you see a two-way DROTA, this router and the other router can only exchange hello packets. They cannot go into the state of trying to exchange link state updates and advertisements. So let's try show IP OSPF neighbor here. Okay, so again you can see this is between R1 and R2 full BDR. Okay, so they can exchange hello packets, link state updates, queries, replies, acknowledgements. The same with router 3. That's how router 1 sees 2 and 3. If we go to router 2, this is how router 1 sees router 2 sees router 1 and 3. Full DR. Okay, let's try router 3. Okay, just do a show IP OSPF neighbor. Okay, full BDR, full BDR. Okay, so none of these routers is a DROTA. Okay, these routers are either a DR or a BDR. There's no two-way DROTA here. Okay, so let's have a look at the next part where we're going to change the IP OSPF priority value. Okay, so at the moment this is all on 111. Okay, so what I'd like us to do here is let's try change this priority value on router 2 to a higher priority number. Okay, so what's important about the priority value is that a value of 0 does not become a DR or a BDR. Now by default it's 1, which means that a value of 1 right up to 255 on the interface makes it more likely that the router becomes the DR or the BDR. If you set it to 0, it does not become a DR or a BDR. So let's say we change router 1. Okay, so we change router 1. So go conf t router OSPF 10. Then we go, just put a question mark. Okay, so you can see here we have oh, hold on. Oh no, let's go exit. Global config IP OSPF. Put the question, OSPF priority. Oh, it's not picking up. Let's go exit. Let's try from between. We have to do this in interface mode. So int G01. Okay, IP OSPF. Okay, there you are. Priority. Put a question mark. You see from 0 to 255. So I'll just try make this 0. Okay, and that do a WR, and let's try do a show IP OSPF neighbor. Okay, hold on, let's try OSPF int. Okay, so you can see that state is DROTA now. Notice that between gigabit 01. Okay, so this interface has reached the state of DROTA. It's neither a DR nor a BDR. Let's see the relationship between R2 and R1. So let's repeat this. Okay, let's also go. So we've changed that to 0. Let's change this conf t. I'll go interface G01. Let's try IP OSPF priority of 2. Let's observe what happens. So IP OSPF int, and we are now forcing, okay, because the priority value is now gone up, this should now change. Okay, force this to change. Gigabit 01. Okay, let's try go back here. Conf T. So hold on. Oh yeah, let's do exit. So IP OSPF neighbor. Okay, so notice between router 3 and its neighbor router 1, gigabit 00, that's a DROTA full and it's DROTA. Between router 3 and router 2, full BDR. Okay, full BDR. So if I go to router 3, router 2, and I do show IP OSPF neighbor, again you can see that it's full DR. So what that means is router 2 is now the DR and router 3 is now the BDR. It was that router 3 was the DR, but we've now changed that. Okay, so this now becomes the BDR and this is now the DR. Okay, simply because we changed this priority value to 2. This was 0, 1, and we set it to 0, and this is 1. Okay, so 2 becomes the DR, BDR, and this is a DROTA. Okay, so remember that you can modify or you can influence the DR or BDR election in a multi-access network simply by modifying the router ID or even the priority value. Again, the priority value, modifying the priority value would be a recommended method, especially to do with links. If you are looking at links, here in this case, because all of these links, these connections between the 3 routers are all Ethernet, the default is 1. So it also comes back to the type of interface, connection between these routers that impacts the type of the priority value that is assigned to the interface. Okay, so each interface has its own priority value, and here the default we saw was 1 across all interfaces, and we had to modify that. Okay, so the last thing I would like to do here, and probably cover cost in a separate video, is to do a propagate the default route. Okay, so let's go to R2, and we would want, because R2 is the interface connected to the internet, simulated internet, we want to do a default route. Okay, so remember when you configure a default route, that default route is more or less the gateway of last resort. And this gateway of last resort, in this case that we're using, we want it to be the connection to the internet. And then we want router 2 to share that information with router 1 and 3 also. So IP route 0, 4, and interface, I'll just put a question mark in there. Notice we want to specify not a next hop interface, but an exit interface. So this will be LO1. Okay, so LO1. Let's do an exit. Do a show IP route, and you'll see somewhere down here that the gateway of last resort has now been set. It's a static route. So I want OSPF to be able to propagate this information. So I'll go conf T router OSPF10 and I type default information originate. Okay, so default information originate, and that do a WR to save. If I go to R1 and I type show IP route, show IP route should have some information about it, about this. Okay, so here it says, okay, that's an OSPF E2. Okay, so let's see what E2 represents. E2. Okay, so it's an EIGRP, OSPF. Okay, and notice the asterisk there. Okay, it's a default route. Okay, it's a default route. And E2 means it's an OSPF external type 2 default route. Okay, so notice OSPF was able to share that info with router 1, and how router 1 can be able to reach that is via gigabit 00, and that's this interface here. So it seems R1 is not going directly, it will go across to router 3 and then router 3 up. Okay, again, it makes sense because I placed this interface as 0. Okay, I set it to 0, that's why it's not going to go that way. If I change this to 1 and this to 0, it should now change. Okay, so let's just try modify that. Okay, it's always good to try things out to see what impacts it has. Route, hold on, int G00 IP OSPF priority, I set it to 1 again, exit, int G01 IP OSPF priority, set it to 0 and do a WR, and then I'll try a show IP route again. Okay, so it will take time. I'll just fast forward that. Okay, so it's still going via G00. Okay. Still going via G00. Let's check this one. But anyway, I think I need to set something up also. Do show IP route. You can also see the same here. OSPF, it's an external type 2 route, and it's a default route, and via 10.1.1.9. 10.1.1.9 is pointing this way, gigabit 01, so it's going right across. Okay, so how networks in this connected to this router will reach that is via that interface. Okay, so I think by now at least you have a fair idea of why OSPF, or how to configure OSPF version 2 single area, and how the priority value can be modified, how the router ID can be configured, and how the priority value and router ID are able to influence the DR and the BDR election. Okay, so remember the DR-BDR election only happens in a multi-access network. A non-broadcast point-to-point network, you don't really need that. Okay, you just have only 2 routers interconnecting. Okay, so probably in the next lesson we can look at the cost metric, OSPF cost metric. Okay, thank you.